Hi everyone. All right, it's time to review. Your quiz is coming up, so it's time that we do a little bit of studying, right? On our quiz, I'm going to ask you about solid, liquid, and gases, and the atom and the periodic table. So, for those of you who don't remember what we did before spring break, let me go over it. For those of you who are just joining us, welcome. Let's go over that new material that you weren't here for. So, we have three states of matter. We have solids, liquids, and gases. Solids, as we can see here, they have a clear shape and volume. That means their shape does not change. A solid, like my phone, is going to stay this shape. No matter where I put it, it's always going to be the same shape. The atoms of a solid are really close together. You can see that here. You can see how close the atoms are. And they still have energy. They vibrate in place. They don't move. They vibrate. They still have some energy. Now liquid is similar. Liquid is another kind of matter. It has a clear volume, but it has no clear shape. That means if I take this liquid here, I'm back. If I take this liquid and I pour it from this bottle into my hand, it's not going to stay the shape of this container. It's going to become the shape of my hand. Liquid matter changes its shape. It changes the shape and takes the shape of whatever container it's in. Liquid atoms tend to stick to each other and to whatever they're touching. The other important thing to remember here is that liquid atoms are close together and they're constantly and randomly moving around each other. Now what that means is liquid atoms are close together, but they're always moving. Liquid atoms are always moving around each other, not very far away. Solids are together. Liquids are moving around each other. Now gases have even more energy. Gases, instead of being here, they're out here, and they're full of energy. They're going everywhere. Gas atoms, or the atoms of a gas, they're far apart. These particles move quickly in all directions. You can see that here in these pictures. These atoms are really far apart. All right, everyone, that's what we need to know about solids. Now, let's go on to atoms. Remember, our atoms are tiny. Tinier than an apple, tinier than the seed, tinier than the ladybug, tinier than the little piece of pollen inside the ladybug's antenna, tinier than the small tip of the pollen, even tinier than that. Got to go all the way to 0.2 nanometers to see these things. They're so tiny. Atoms were thought to be the smallest thing for the longest time, but we now know we have three subatomic particles. Subatomic means smaller than an atom or below an atom. Sub means below, atomic means atom. So we have three things below an atom. We have protons, electrons, and neutrons. Now there's two important things you need to know about protons, neutrons, and electrons. And those two important things are, you need to know their relative mass. How big are they? How much do they weigh? And you need to know their charge. Are they positive? Are they negative? Are they minus? You need to know what they are. So if we look at this chart, we can already tell a couple of things that we need to know. We can see that proton is positive. Let me move here. Whoa, here, go up. All right. A proton is positive. It's got a mass of 1, and we find it in the nucleus. The nucleus is the center of the atom. Neutron has a 0 charge. It's not positive or negative. It's a 0 charge. It also has a mass of 1. Just like the proton. And like the proton, we can find the neutron in the center, like you see in this picture. The neutron and the proton is in the center. The center is called the nucleus. An electron is negative, and it almost has no mass because it's so small. Ooh, sorry guys, it's late at night. All right. Electron is very small. No mass, but it does have a charge, and the charge is -1. Now we find an electron in the orbitals. The orbitals are also called shells. The shells go around the outside of the nucleus. This is the nucleus, that's the middle with the neutrons and protons. The electrons go around the outside. Alright, this next slide kind of says the same thing. It does have one important bit of information, and that is there's always an equal amount of protons and neutrons because it keeps an atom neutral. In order to keep an atom neutral, that means we have the same amount of pluses and the same amount of minuses. In order to have pluses and minuses equal, we need to have the same amount of protons and electrons. So there's always going to be the same amount of protons and electrons. Alright, here's another picture of what an atom looks like. Again, nucleus is in the center. The nucleus has protons and neutrons. That's the center. The electrons hang out in shells. That's the circle on the outside. Each shell has a name. This here is the first shell. This is the second shell. The next one would be the third shell. And then we would have the fourth shell. First shell is always closest to the nucleus. Now the first shell can hold 2 electrons. The second shell can hold 8 electrons. And the third shell can also hold 8 electrons. Alright, that's the basic of what an atom looks like. Now let's get talking about the periodic table itself. There's a couple of things we have to know. There's so many numbers here, and we need to know what each of these numbers mean. So, looking at like a small sample, we're going to take this periodic table and we're going to zoom in on sodium here. We're going to zoom in on that. Let's go in. And here we see sodium. The Na here is the symbol. Above this symbol, above the sodium symbol, we have an 11. That 11 is the atomic number. The atomic number is equal to the number of protons. The number of protons. That is the atomic number. Now, since we always have the same amount of protons and electrons, the atomic number also tells us how many electrons we have. Now, there's another number down here, right? Below the symbol, below sodium, we have the atomic mass. This is how heavy the atom is. Let's take a look at that. That number is known as the mass number. The mass number is equal to protons plus neutrons. So if we add together protons, I'm sorry everyone. If we add together protons and neutrons, we get the atomic mass. Here's a couple of examples. Hydrogen has 1 proton, 0 neutrons, so its mass number is 1. Lithium has 3 protons and 4 neutrons. Its mass number is 4. There's a lot more examples that you guys can go through, especially in your notes. The mass number here of helium would be 4 because we have 2 protons and 2 neutrons. Mass number here would be 29 plus 35. To get neutrons, we would subtract the number of protons from the mass number, as I did here. And to get the number of protons, we would take the mass number minus the neutron number, and that will give us the number of protons. Alright, let's see what else we have. Protons almost never change. They're almost always the same. There's only a few places on Earth where we can actually change the number of protons. The sun, stars is an example of where we can change the number of protons an atom has. The sun is really hot and atoms are moving around very fast there, so the sun can actually push together atoms and fuse them. We can't do that on Earth yet. Now, what we can do on Earth is we can split an atom apart. We can split protons off, and when we do that, we get a big explosion. Alright, so far so good. Let's go over the last thing we need to know about the periodic table. The periodic table is made up of metals, nonmetals, and semi-metals. Our metals are here on the left side. These are our metals. This orange here, these are metals. Our nonmetals are here on the right side. The nonmetals are in red. Now, please know, hydrogen is a gas. Since hydrogen is a gas, it is a nonmetal. Hydrogen is a nonmetal, but it hangs out in with the metals. It hangs out in group 1 because, as we'll find out in a moment, it has 1 electron in its outside shell, which makes it part of group 1. But please know that hydrogen is a nonmetal. Now these green elements in the middle, these green elements are known as the semimetals. They have properties of both metals and nonmetals. Now let's take a look here. Metals are always shiny. They tend to reflect light. Nonmetals are dull. It's easy to see. Look at this sulfur, a nonmetal, and look at this nickel, a metal. Look how one is really reflective. It reflects light. It's very shiny. Metal is malleable, meaning we can bend it. I can take metal and I can bend it. If I take something like my phone, which this glass is not made out of metal, if I try and bend it, I will break it. Mostly nonmetals will break if you try and bend them. Metals can be hammered. Metals can conduct electricity. Nonmetals cannot conduct electricity. All right, 2 more things we need to know. All right, our periodic table can also be organized into groups and periods. Groups go up and down. They're columns. Groups share properties, but more importantly, they have the same number of valence electrons. Valence electrons are the electrons on the outside shell. Valence electrons are the electrons that are on the outside shell. Now, the group number is going to be equal to the number of valence electrons. So, in group 1, you have 1 valence electron. In group 2, you have 2 valence electrons. In group 3, you have 3 valence electrons. Group 4 is 4, group 5 is 5, group 6 is 6, group 7 is 7, group 8 has 8 valence electrons. Now, what about this group in the middle, Mr. Angling? What about this? Why is this? This is its own group. This is called the transition group. The transition group deserves its own chapter. It doesn't play by the rules of the other groups. And we'll have to discuss transition groups another day. All right. Last one. Periods. Periods go left to right. Left to right. They're horizontal. Periods go left to right. What periods tell us is the number of shells in that element, the number of shells that atom has. So, for example, period 1 has 1 shell. Period 2 has 2 shells. Period 3 has 3 shells. Period 3 has 3 shells. So this is a quick way of drawing the atoms, right? We can use periods to figure out how many shells we need to draw for our atom, and then we can use groups to figure out how many electrons are on the outside of it. Hopefully that helped. Good luck, everyone. I know you'll all do great. I'll see you in class tomorrow. Good job. Bye, everyone.